Awesome. Thank you, AJ. Thank you again for allowing me to be part of this InterNACHI experience. It has been a great experience so far. Welcome to Electrical 101 Part 2, and this is bonding and grounding. When I am a certified electrician, I went to school for it in 2015, and instead of doing electrical, I actually went into home inspections, and I love it. I've done over 3,000 plus homes. I like to mentor and train other home inspectors across the country and answer questions when I can. So we got a lot to go through tonight. So if you do have questions, you can type them up there. I might not get to them right away though, because like I said, we got a lot to cover. Bonding and grounding is kind of one of those things where a lot of people get confused on. So we thought it was a great idea to actually talk about it and really dive into it so everybody gets a good understanding what bonding and grounding is about and why it's so important and stuff. And if you have a one of these books, the NEC, remember that the NEC is a book of guidelines, and some jurisdictions do not adhere to every little part of the NEC. So just kind of keep that in mind. Okay. If you haven't checked out Electricity 101, I recommend that you do check that out later, or um, hopefully you do anyways, because it has a lot of the groundwork for this. So grounding and bonding, it prevents a lot of stray voltage. I've had other inspectors actually call me and say, I've had electricity on a GFCI that's been tripped. Well, that's stray voltage. Sometimes that does happen, but it eliminates the potential when you have a grounding and bonding. So, of course, right when I get into it, somebody calls. Love it. It also reduces arcing and fire risks. Okay, it stops that dangerous sparks between unbonded metal parts. So if this was metal and this was metal and I have that bonded together, it has a less chance of arcing or having fire risks. Okay, it also keeps plumbing safe, and I'll go into a little bit more detail about that and tell you about when I was training for being an electrician. It also ensures consistent electrical potential. We want to see zero when it hits the ground. That's the biggest thing, is everything should be equalized across all metal parts, okay? And that will help stop the shock hazards, and it keeps everything that same potential right across the whole board, okay? Um, it is in the NEC Article 250.1, and that's where the grounding all starts right in that section. So you can always go to 250 and you can go through all the codes. And maybe one of these days I'll actually do a webinar on how to read the NEC, because I have so many people that call me and they're like, I don't understand it. And so I'm thinking maybe that might be one of the new webinars that I'll do. So, anyways. Um, Okay. What we're going to actually discuss tonight is the fundamentals of electricity, source to source, and we're going to understand the circuits and bonding and why it's so important. Okay. When did grounding and bonding really be addressed? Does anybody know that? You can actually type in your answers if you want. We're going to try to keep this interactive for the most part. But like I said, we do got a lot to cover. So if you want to put some answers in there, when do you think bonding and grounding actually was addressed? Not seeing too many answers here. That's okay. Bonding and grounding actually was in the 20th century when grounding systems started gaining attention with the increased use of electricity. Electricity was actually invented way before then, but it wasn't till the 1900s when it really started becoming popular. People actually built houses and they still ran the gas lines because they thought electricity was going to fail, believe it or not. And that's cool. So when you do older houses, really old houses, sometimes you'll see those tubes of um, gas lines still in the walls. So pretty cool stuff. In the 1920s, by this period, the NEC was formulated the ground requirements, and their book was actually like a size of like a notebook. That was it. That was the whole requirements for NEC back then. In the 1960s, the importance of grounding actually became more important and they started realizing that people were getting shocked and they were getting burned so often that they had to do something about it. And so in 1971, the NEC explicitly required bonding and grounding to work together to improve the safety of people and actually help against the lightning strikes. So pretty cool stuff there. It protect the protection in the electrical devices too. Electrical components with regulated rules enhances device longevity and promotes overall peace of mind when you and your loved ones understand the whole fundamentals of bonding and grounding. So how does electricity move? There is a good website you should go to. It's Mike Holt. He actually helps write the NEC. He's like one of the most influential people around, and he has a lot of good videos about bonding, grounding, everything to do with electricity. So if you want to do a screenshot on this, and you could probably watch a couple of his videos. Some of them are really I think they're exciting, but some people think they're really boring. But whatever, that's up to you. But electricity flows, and if we're looking at a battery, it actually goes from negative to positive. A lot of times, like the older vehicles actually used what they call the positive ground. And when you were jump starting a vehicle and stuff, you really had to be careful because you could blow up the battery because you actually put it on the wrong side. Now, negative is always ground in all vehicles except for a few that were bad. So, anyways, kind of fun stuff. Um, so, doing this brand new house here, and do you see a grounding wire anywhere there? It's actually right there. And there is no grounding wire that goes to it. And it passed inspection with the electric company or sorry, the electrical inspector. They did come back later and I actually verified that it was there. So things like this actually happen, believe it or not. Brand new house too. And it was pretty much move-in ready except for they didn't have the ground. So, what is grounding? Grounding is a process or idea of directing access energy to the ground via a wire. Known as a grounding wire, it is an essential safety component in most electrical system. The grounding wire will discharge excess excess electricity safely to the ground so that it doesn't cause injuries or fire. Um, Now, the cool part is that grounding is really important. Does anybody know why grounding is so important? If you've been listening, you should know some of the answers. Anybody got any thoughts why grounding is so important? Give a few seconds here. All right. The primary reason that's true. Injury protection provides a safe path to the ground. You are both correct, but the primary reason for grounding is to protect people from electricity shocks by providing a safe path for electricity to flow through the earth instead of through a person's body if a fault occurs. Okay. Um, there was a story I heard that this light pole was actually causing it was on a metal pole and it was causing people to get electrocuted as soon as they touched it. So their idea is to drive a grounding rod into the ground for that electrical to disperse. Well, a dog came up, peed on the electrical or peed on the lamppost and actually died because they grounded too much. So that is the importance of grounding and understanding why. So what did we learn from Electricity 101? We learned that electricity flows everywhere and anywhere. It doesn't care. It just wants to get back home. One of the courses I took said that electricity always wants to find its way back home. No matter where you're at, it wants to find its way back home. And it doesn't care. It will flow. So love it. Grounding is to or from our planet. And in case you don't know what our planet looks like, this is our planet. It actually flows through it. Yeah, electricity is actually everywhere. And if you go to Electricity 101, I talk about the electrons and how they flow and stuff like that. And I try to make it as easy as I possibly can because it's like I had to go back to fifth grade when we did all that fun stuff in science class. And I wish I would have paid more attention back then. Now that I'm older, I'm looking back like, man, I had all these good teachers that would have taught me this. So the Earth resistance is measured in what we call ohms. Ohms is the measurement of resistance. So remember ohms, that little sign that it's actually a Greek sign, I believe, and it is what we use to understand how slow electrons flow. So one of the main things that you probably don't hear too much is electricity drop. And what can happen is when you have wires that are attached to an electrical system or voltage drop, sorry, and it's going over a longer period or a longer strand, what can happen is because of the wire being so long, it actually drops the voltage across that wire. So that would be your resistance, that would be your ohms that is causing that. That is basically all your electronics and everything else is actually slowing down and speeding up electrons through um, your circuit boards and things like that. That's what its job is to do, is to slow down and speed up. And if we understand ohms and how they work and how the earth is set, we can actually figure out the type of resistance that the ground has in certain areas too. So I think I'm going to get into detail about that a little bit. I'm jumping ahead of myself, but that's all right. Different types of soil also have different resistant capabilities. Like I was saying, clay has a resistance um, as low as 20 ohms, where rock and sandy soils have 3,000 ohms because they're spaced out a little bit more. And as they continue down the path, it lessens and lessens and lessens. So kind of cool. Myths to be aware of. This was kind of my fun part of this whole entire webinar is checking out these myths and hoping that this could actually give you guys some good talking points when you're doing inspections and stuff. A lot of times I like to throw in fun facts and stupid stuff so that the customer doesn't really get bored. So electricity always takes the path of least resistance. That is actually false. It takes Electricity does tend to follow paths of lower resistance. It doesn't exclusively follow the paths of least resistance. In some cases, especially with high voltage or specific conditions, electricity might take multiple paths. So that is why grounding and bonding is so important, because we need to try to control that electricity as much as possible. If you've ever seen an arc flash, the arc flash will actually run through the air. I've heard of people having sitting down and actually seeing like a lightning strike come from the receptacle and then going right to the copper pipe. And it's crazy stuff. Rubber insulates completely. Does everybody know that rubber does insulate? It's a great insulator, but it doesn't um, insulate completely. It is completely impervious to electricity. It isn't, sorry. And the high voltage or prolonged exposure to electricity can actually cause rubber to break down and conduct electricity. So be aware of that. That's why you see like electricians and stuff, they'll put on those big gloves. One story I have is that this plumber was doing this complex. It was a multi-unit complex, and he had to shut off the water. And so what he did is he opened up the water shutoff and he put on these welding gloves over some insulated gloves on top of that. And then he reached down there and turned off the water. Well, when they actually tested for electricity on those pipes, it was actually reading 120 volts. So there was some leakage coming through and going right to that pipe. And so if he would have touched that, he would have definitely got electrocuted. So it is very important that we understand electricity and how it works, and how dangerous it can be if it isn't controlled properly. And eventually, I believe they did figure out what complex it was and figured that out. But that was part of my electrical training that this guy put on his gloves and stuff. So lightning never strikes the same place twice. I don't know how many people know that lightning actually does, in fact, strike the same place and multiple times, especially tall structures are often struck repeatedly during the thunderstorms. Benjamin Franklin came up with this idea of the lightning rod, and we're still using that same method today that he used. He realized that if he was able to put a big rod up on top of a building, it would actually cause the electricity to hit that, and then he could disperse it down safely to the ground. Saved hundreds of houses and also a lot of church steeples top of it. So here are some pictures of lightning striking the same building several times, and um, I stole this from the internet, so hopefully this guy gets some good publicity. Anyways, electricity can leak out of electrical appliances. That is also false. Electricity never leaks out of appliance unless there's a faulty wire or insulated issue. Appliances not only use electricity when they're turned on or connected to a power source. So just so you know that when you do plug something in to an outlet, that cord also has some resistance to it. So you are actually drawing a little bit of voltage through there, even though you're not actually running your appliances. So just know that too. So if you had your whole house and nothing's plugged in, you are going to draw a little bit of electricity because the electricity is still running through those wires. So pretty interesting, huh? Especially if you have those transformers for your cell phones and things like that, that's sucking up energy. So birds sitting on a wire power line don't get electrocuted. Now, I actually found a picture of this and I decided not to put it in there because it's gross. So while it's true that birds can sit on a power line without being electrocuted due to the lack of complete circuit, they can still be electrocuted if they touch two power lines at once or if they touch a power line and another conductor simultaneously. So birds do get electrocuted. Just doesn't happen all the time. Electricity travels at the speed of light. This one I was actually shocked because I actually thought it did. It doesn't. Matter of fact, it actually goes a little bit slower, close to the speed of light, but and that's in a vacuum. It actually travels much slower through conductive materials, and that's when you get that resistance factor. And turning off all appliances stop electricity consumption. I think I already covered that. They do draw a small amount especially when they have that standby button. Okay. Grounding rods prevent electrical shocks. Now, you heard me say about that lamp pole. While grounding rods are an important part of electrical safety systems, they don't alone prevent electrical shocks. They provide a path to safely extravagate that path to the ground and give it back to its source, which is normally your transformer, and that's what it's for. Uh, I wanted to show a video here, but I can't get it up and running, and it actually shows electrical interference when there was some wind and it was grounded wrong, and the fence was actually touching the ground, and as it moved, the light on the building would flicker. So if you look at some of my old videos, I got that on there. And then later on, you can actually put a grounding, or sorry, a wire in the ground and actually touch the electrical or touch the fence, and it's actually electrified. So that was pretty cool. Grounding rods eliminate lightning strike. That is not true. Grounding rods do not. And you can see that I put that big and bold. Do not eliminate lightning strikes. Instead, they provide a safer path to the lightning's electrical energy to dissipate into the ground. However, lightning can still cause damage to electrical systems despite proper grounding. Now remember, electricity moves anywhere and everywhere, so it can actually go up the grounding rod into your electrical system too, especially if it's that lightning is dispersed somewhat close to that grounding rod. Okay, multiple grounding rods also improve safety. That is also a myth. Matter of fact, it actually causes more harm than good. Additional grounding rods can enhance the effectiveness of grounding systems. There is a point of diminishing returns. Poorly spaced or redundant grounding rods may not efficiently improve safety, and they can actually cause or create grounding loops, which could potentially cause injury or death. So we don't want to have that. Understand the functions and the limitations of grounding rods is essential for ensuring electrical safety and proper system operation. Consulting with a qualified professional and adhering to the local electrical codes is crucial for installing and maintaining effective grounding systems. So if you have a networking group or something like that that you're with, get together with that electrician and really keep his number on speed dial so that you can have a good relationship with him so that you can actually ask questions if something does occur and you're like, you know, something I'm not really sure about this. What does the electrician say? Because they know a lot more than what we do. I know, you know, from the 2015 when I went through my course and I tried to keep up with it, but honestly, I don't know everything either. So that's something I do recommend everybody understand. So this is what your typical grounding rod looks like. It goes 8 feet into the ground. You have to have it 6 feet apart from another grounding rod in most jurisdictions. Some jurisdictions say only one grounding rod still. Matter of fact, when I was in electrical school, they actually told us not to put the grounding wire up like that. It actually should go down, pointed down, just in case electrics or a lightning strike hit, it would actually bounce up and hit the siding. But there's no rule or anything that says that it has to go up or down in that clamp there. So that's what they look like. Here is one that is actually a continuous grounding wire there and multi-strand. I don't think that is legal anymore, but you will see that every once in a while. Okay. What is bonding versus grounding? Bonding involves connecting metal parts to one another to give electricity the same potential. So if I hooked up a voltmeter here and had it on ohms over here and I had a wire between the two, that should be the same potential between these two objects if these were both metal. Okay, that's what the difference between bonding and grounding means. Electricity always will find its way back to any or all parts. So electricity, it's like the wild child. It'll go anywhere and everywhere, okay? There's a couple of grounds that you'll see, especially like up north from when I was in Minnesota, we would see a lot of grounding wires attached to the plumbing. Then you'd have to have your jumper wire over that meter there, and that's exactly what we see here. I also seen some on plastic PVC pipes. I don't know what that's doing, but whatever. Here's your grounding rod as you see before. The grounding ring, you'll see a lot of grounding rings, especially around pools. Pools have to be grounded very interlocking because water is a good source of electricity flow. It does have some resistant qualities, but people can get electrocuted in a pool if it isn't grounded properly. Mike Holt has another good video about that where he's actually testing ground, um, the ground when he actually energized the ground in his pool, and he actually was able to swim right. But once he got out of the pool and put one foot in a different area, he was actually getting electrocuted. So pretty cool. And oofer ground is when it's encased in a metal, or sorry, in cement, and you'll see those a lot, especially on slab on grade. Um, Buildings and things like that. Steel structures all have to be grounded. In certain areas, you have to ground your siding if it's metal. So things like that, so that everything becomes that same potential across the whole board. Okay. Again, grounding the gas pipe now is essential because, of course, gas is flammable, and you want to make sure that that is bonded properly to the electrical system, so it has a way to disperse properly into the electrical system and find its way back to the source. Basically, is what you want to do. Any metal parts whatsoever should be bonded together, especially in an entire house. So, I love InterNACHI. They got a lot of good pictures and stuff like that that you can pull up if you're an InterNACHI member and actually use those for teaching people and actually using them for yourself, especially like your reports. You can actually pull them up and show people what you're looking at and why you're looking at. So for gas lines, bonding is crucial to prevent electrical current from energizing the pipes. We definitely don't want that to happen, but they should not be used as a grounding path with grounding rods. Yeah, that sounds really smart, right? This prevents safety risks like stray currents damaging the pipes or causing arcs. Um, so I was doing this one house, brand new house. Matter of fact, it was whole complex here, and this is a gas meter here, and you can see that it's grounded to two spots. Well, according to, I believe it's 75 in the, uh, the, ah, drawing a blank here, the NFPA, which is the National Fire Prevention Association, they actually say that it has to be bonded into the electrical system within 75 feet, I believe it is. And here's what the clamp looks like, but it actually has to be bonded. And I will see things like this in attics where they actually took that bonding strap off the piping. And we want to see that especially on gas pipings with that CSST, the corrugated stainless steel tubing, because it's such a thin material that if it does get hit with electrical current, sometimes it'll actually blow out of there. Or I mean, electrical lightning strike, it could actually blow out of there. So a lot of electricity wants to get out. It wants to get back to its source as fast as possible. So that bonding your electrical to, or sorry, bonding the gas to your electrical is the proper way to do it. And so that was definitely called out there, and hopefully they fixed it. I never see a lot of the end results once I do a home inspection, every once in a blue moon, but that is definitely a no-no. We want to see that attached. I've seen a couple of houses that have actually burnt down here in Florida. In the Central Florida area is one of the most lightning strike capitals of the world. People have been brought in just to see the lightning strikes, and one of the houses that wasn't too far from here actually had that happen. They didn't bond the gas to the electrical system, and well, lightning hit the house and actually blew out the whole gas and blew up their house basically. And so it's a pretty sad deal. And a lot of people where I live is a lot of elderly people, and so just sad all around. So grounding and bonding. Here is a good illustration of the grounding and bonding. You can see where the water meter is. You got your jumper wire, so that connects the entire system together. And we want to see that jumper wire, especially because the electric or the water meter runs small voltage there too, and we don't want that to burn out. So it kind of gives it a safer path if it does ever get energized. So we do want to see like copper pipes especially have those jumper wires across even your water heater, and we want to see that all bonded together through the electrical system and then grounded into a grounding rod. So that's pretty much how the path of electricity should flow. And does that, can you touch on bonding jumpers for CSST across manifolds? The best thing is okay, so bonding one part of it normally should uh, take a lot of that energy to the main panel. Having more jumper wires, I think you'd be all right on that, but I don't think there's anything that says that you have to, as long as you have the main um, bonded with the electrical system, if that's what you're asking. So all right, onward to this. What things should be grounded? What things should be bonded? Okay, just like Robert just asked about the CSST, that definitely needs to be bonded, of course. So let's define bonding. Bonding connects metal to metal parts. So it connects metal parts together so they ensure all the electrical same potential. So if, like I said, if I took an ohms meter and I have this bonded with the microphone, there's a wire in between. I should be able to put it anywhere on any of this system here, and it's going to end up causing or should have the same potential. It should be at 0 um, ohms. That makes sense. Okay. Bonding medical metallic electrical boxes, all metallic electrical boxes, junction box should be bonded. Ensure that the same potential is in conductive parts. Conduit systems should be bonded throughout. I like using conduit, especially like metal, flexible conduit and stuff, but you got to make sure that that's all bonded together so that everything has the same potential. And a lot of times I'll use that metal conduit system as the ground. So when I ground things together, piping system, metal water pipes and gas pipes should all be bonded together. creating one giant loop basically. Grounding electrode systems, components of the grounding electrode system like grounding rods or plates should be bonded together to form a continuous grounding path, just like everything else. Electrical panels, the metal enclosures of the main electrical panels should be bonded to the ground bus bar within the panel. Now, when you're looking at sub panels, they should be separated. Okay, bonding jumper not. Sorry, I'm reading this here. Bonded to the direct conduit exceeds 75 feet in length. Yep. Bonding between. Dude, you got a lot to read here, man. The must connect to the rigid steel pipe brash. CSS must never connect directly to the tubing itself. Exactly. Clamping directly to the could result in poor electrical. You are correct. So is that Robert? Thanks, Robert. That's good. Proper bonding reduces the chance of stray voltage and ensures electrical systems remain safe under fault conditions. Always refer to the National Electric Code and local regulations for specific bonding requirements. Like I said, in some areas, they say one grounding rod instead of the two. Just FYI, I've ran into it a few times here. Not too often, but I do run into it every once in a while. Define grounding. Grounding connects the electrical system to the equipment to the earth to safely dispatch fault circuits. Um, Grounding electrode system. This includes grounding rods, plates, or other types of electrodes that connect the electrical system to the earth. Electrical service equipment. The neutral bus bar in the main panel is typically grounded together. This is the point where the electrical system is grounded to the earth. So your neutrals and grounds have to be connected at the main panel only. After that, it has to be bonded throughout. Equipment grounding conductors, all exposed metal parts. We've already covered that, like appliances and tools should be grounded to ensure that they are at the earth potential, which reduces the risk of electrical shocks. Receptacles, electrical outlets should have grounding conductors connected to ensure that device plugged into them are properly grounded. Ground fault protection, those are your GFCIs, should protect and other protective devices should be installed in locations where grounding faults are at risk, such as wet or damp locations. We should all know that by now, especially if you're a home inspector. Okay, again, we go back through the entire system. Okay, we want to see jumper wires, and just like Robert was saying in the chat there, you actually have to have your gas bonded, but you can't do it on the CSST wires, I believe was what I was reading there. I had to read it pretty quick there, but there was a lot there. People, you can read that. The cold water supply and your hot water supply, if they're metal, you have to bond everything together. It all goes back to the electrical system, back to the ground. Hopefully you understand this, okay? What I want to touch on now is something that's new in the 2023 electrical code is the surge protection. Okay. Now that we understand the bonding and grounding, well, a lot of times what will happen is you get these surges, a lot of times from the source, which is your power plant, and or you could have a lightning strike and it can surge up there. So we want a place where it will not disrupt as many components as possible. It's still recommended to actually have those surge protectors on a lot of your devices and stuff. I have one on my computer and my TVs, everything else, and I have the surge protector so that in case there is a surge of energy, I want it to dissipate that, not my appliances, because why not? Um, so anyways, a lot of times they used to be on the bottom of the box, but they've have made them now where they actually sit inside the electrical panel itself, and it will blow out if it gets overcharged. Okay. Surge protector devices, the SPD, in dwelling units, in dormitories, guest rooms, and guest suites or hotels and motels, areas of nursing homes, limited care facilities, used exclusively as outpatient sleeping room. So this is NEC 215 18A. Um, you'll see these a lot now on new builds. They're starting to become uh, pretty common on every new home construction. And if you upgrade your system, you might want to just ask for those surge protection devices. So it's actually called an MOV. What is a MOV, you may ask? Of course you do. It's a metal oxide varistor. So it's an MOV. What happens inside here is that if you had a surge, it basically blows a fuse. That's the simplest thing I can say. And so that your components will feel it, but it's not going to feel the full effect of the surge, depending on the electrical spikes, of course. They typically last about 3 to 5 years. Some people are saying that they can last up to 10 years. So far, I haven't seen any um, studies on how long they last because they are kind of newer. So as years go by, these surge protectors may last even longer than that. So bonding, let's go back to the bonding and grounding. So bonding is connecting of metal parts together. This makes everything the same electrical level, keeping electricity somewhat controlled on the right path where it's supposed to be and out of the places where it shouldn't be. Like I said, electricity is like the wild child. It likes to roam, it likes to run, it likes to go in every place it can. So if we can control that as much as possible with wiring and things like that, that's where we're going to be safer. One of the most important parts of home inspection is the electrical system because I believe it's like the pulse of the building. And if it isn't safe, for your clients, then it isn't, or if it isn't safe for your clients, it's not safe for you. And if it ain't safe for you, you definitely need to call out an electrician to check those out. So the recap is grounding helps electricity find its way back to the source when there is a fault like a short circuit. Okay, that's bonding and grounding. They work together. They keep things safer by following electrical safety protocols, mostly found in the NEC. Now, like I said, every jurisdiction is different. So if you really want to dive into different jurisdictions, that's city, that's county, that's state. But most of them all adhere pretty closely to the NEC. So if you get to know that NEC, be safe. That's the biggest thing. And you're better off to be safe than sorry. I always recommend licensed electrician. I just talked to another home inspector here, and he had some issues with this electrical panel. And I said, you know, if you're in doubt, call it out. And he's like, well, it's a Challenger and this and that. And I said, does it have the stub lock breakers in there? And he's like, I don't recall. And I was like, well, then call it out and say further evaluation because Challenger did get bought out by another company and they pretty much fizzled anyways. So call it out, be safe. Okay. I always keep that out. And we got some time for questions. I actually ran through that a lot quicker than I thought because I was talking a little faster. Um, you can always email me at askdirkcmi@gmail.com. Let's open this up for some questions and see what people have um, out there because I would like to make this more yours than mine. Every time I ran through this, it was like 45 minutes. Should there be a jumper bond from gas pipe over to appliance connectors such as water heaters? Well, the water heater actually should have its own proper ground too. So if you think about it, you still got your ground that goes into the electrical system. So it should be already grounded that way. You say the grounding is at the neutral bus bar. After that, we shouldn't see bonding in the sub panels, right? You are correct. Okay, so what happened was, I can't remember what year it was, but they used to have it grounded at every single spot. The neutrals and grounds were at every single sub panel. Matter of fact, in this house, this was built in the early 80s. They're actually together in the sub panel, but in the main panel, or sorry, they're together in the sub panel and the main panel. What happens is that it doesn't diversify the electrical flow if there was any type of surge or anything like that. So what ends up happening is it kind of makes itself a loop because you got two wires connected. Now, if I spread them apart, You think about the electrical has to run all the way through the entire house, then back around, then into the neutral bus bar. Okay, so that'd be two different paths for it to go. And so it diversifies a little bit more throughout the entire house, making it all one system. That's why we want to see them attached at the beginning of the series, but not at the second series, which would be your sub panels, if that makes sense. You stated grounding neutral. So yeah, that was a big question too. I've had that happen quite a bit, especially like I mentor and train a lot of home inspectors, and I actually test them on that too as we're going through. And it's like, okay, what do you see different here? And they're like, a lot of times I'll do it at my house because I know a lot of the problems here. It's safe, but it's not safe at the same time. You got to kind of look at your what year was the house built, what was acceptable back then. So like looking at the house in the 80s, GFCIs were only recommended every 4 feet from the sink. Now it's the entire kitchen. So it could be a recommendation to upgrade the electrical system in the house. And that's what I always do is just, it's a recommendation. Just you might want to upgrade it. Now, if it's a 1960s house, you don't have any grounding whatsoever, it has that potential to cause electrical fires, and it does have that potential to cause you to have, dare I say it, death. So you want to make sure that the whole entire house is bonded and grounded together to make one simple um, pack together. I don't know how else to describe that. Help me understand the difference better. Thank you. Oh, awesome. I thought you were asking a question there. I'm like, oh, I'm reading that without my glasses on. I must be pretty amazing. See, my wife said I shouldn't eat those second donuts. I think it's helping me. Is it is possible for local codes to override the need for bonding jumpers at the water heater, hot and cold? Any jurisdiction can adopt or not adopt those electrical codes that are found in the NFPA or the NEC. It's all up to that jurisdiction. Um, it's basically this is the guideline, and it's up to you if you want to follow it or not. Same thing like paying off your credit cards. It's up to you if you really want to pay off your credit cards or pay the extra fee. I guess that goes way beyond InterNACHI, but hey, whatever. Yes, this is because common, and I want to be able to call it efficient, but state the local codes may override. So what I do um, in my reports, I go with the NEC. Okay. And we're not code inspectors, we are safety inspectors. If I see something that's not um, in the code, I'm a code certified master inspector, is what my title is. I'll see things that are not in the code, but I'll just say, for instance, if I go into another jurisdiction, I went to one house in brand new build, and there was no outside electrical shut off on the house. And so what that says in the NEC that you have to have a main shut off outside the house for in case there's a fire, you can shut off the electricity in a hurry. Um, but so I put in there, hey, this is wrong, blah, blah, blah. And then I said, but certain jurisdictions may or may not adopt the NEC um, standard. And I just left it at that. So that way I protected myself, but I also said, hey, there might be another loophole here. Further evaluation from the builder and call it like that. That's how I did it. Clarification in class. Hey, thanks. I appreciate that. Check is in the mail. No, I'm just kidding.